Welcome to the Girkship Corrosion channel. My name is Ehtesham Zade. I'm a researcher in the field of corrosion and protection of materials. Chapter 10, Section 8, Corrosion Management, CMS Asset Implementation. The reference is Corrosion Management System Framework and Guidance from NACE International. What's a corrosion management system? A corrosion management program, sometimes called Corrosion Management System (CMS), is the documented set of processes and procedures required for planning, executing, and continually improving the ability of an organization to manage the threat of corrosion for existing and future assets and asset systems. CMS Asset Implementation. This video describes the activities that directly support effective implementation of the CMS for an organization's assets. The processes and procedures for the implementation of the corrosion management plans and activities shall be consistent with the corrosion management policy, strategy, and asset objectives. Ensure that costs, risks, and asset performance are controlled across the asset life cycle phases. CMS asset implementation can be divided into three sections. 1. Life cycle considerations. 2. Legal and regulatory requirements. 3. Corrosion risk management. 1. Life cycle considerations. The organization shall establish, implement, and maintain processes and procedures for the implementation of its corrosion management plans and activities across the life cycle of asset, including 1. Design, procurement, building, and commissioning. 2. Acquisition of existing assets. 3. Operation, maintenance, and update of assets. 4. Decommissioning and/or disposal. 2. Legal and regulatory requirements. The organization shall establish, implement, and maintain processes or procedures for identifying, complying with, and communicating the legal, regulatory, statutory, and other applicable corrosion management requirements. 3. Corrosion risk management. The organization shall identify the corrosion risks or probability of events and their consequence over the life cycle of each asset. Risks should be managed through monitoring, controlling, or minimizing the probability and/or consequences. Effective corrosion risk management relies upon the ability to identify potential sources of the deviations or deficiencies, and then to develop strategies to prevent or mitigate each. Implementation of corrosion management activities. Formal processes and procedures applicable to corrosion management activities include consideration of the following topics. A. Description of the objective. B. Identification of the responsible and accountable organizational element. C. Identification of resource requirements including training, qualification, or certification requirements for organization staff, contractors, manufacturers, or suppliers where applicable. D. Documentation and record keeping. E. Management of change. F. Review and validation practices to verify consistency with applicable regulations, standards, and organization policy and procedures. G. Objective performance measurement targets and measurement methods. H. Scope and frequency of inspections and audits to verify that the objectives are being met, with feedback to a continuous improvement process. Guidance. The information provided in the next slide includes an example of a corrosion management activity, cathodic protection (CP) system installation for an onshore pipeline. This information should not be considered all-inclusive. However, the table provided in slides number 526 to number 536 may be used to assist the organization to develop a corrosion management plan for this activity. The table includes the following information. 1. Potential corrosion management risks that may be encountered during the activity. 2. Recommendations for improved corrosion management. 3. Training and competency requirements for personnel performing the activity. 4. Inspection requirements. 5. Training and competency requirements for the personnel performing the inspection. 6. Applicable records. Additional plans should be in place for the other life cycle stages of the CP system, including operation, maintenance, upgrading, and decommissioning. Consideration for the development of a corrosion management plan for cathodic protection CP system installation for an onshore pipeline. 1. Potential corrosion management risks. A. Creation of undesirable microstructures in the pipe at the site of local attachments. B. Bend-through of thin wall pipe when using an exothermic welding process. C. Poor electrical and/or mechanical attachment. D. Detachment of leads during backfilling. E. Failure to effectively coat the connection. F. Improper installation of impressed current anode ground beds. G. Installation of CP cables with damaged electrical insulation. H. Creation of stray current interference due to improper anode ground bed site selection. I. Reverse electrical connections between the pipeline and rectifier. J. Condition changes between design and installation leading to insufficient CP. 2. Recommendations for improved corrosion management. A. Establish and properly qualify a written joining procedure for leads, which documents the following. 1. Surface preparation requirements. 2. Minimum wall thickness and maximum carbon equivalent of the pipe at attachment sites. 3. Measurement of attachment site wall thickness. 4. Minimum distance from other walls, adjacent lead attachment, or unsuccessful attempts to attach lead. 5. Specification of exothermic charge size range as applicable. B. Provide slack and be aware of wire placement to minimize stress on the lead during backfilling. C. Use an approved coating and coating application procedure. D. Inspect compaction of carbonaceous backfill around anodes. E. Visually inspect and test the area where the anode bed will be installed to identify potential buried structures susceptible to stray current. F. Perform a CP survey to identify potential stray current after installing the pipeline and the CP system. G. Verify the rectifier is properly connected. 3. Inspection requirements. A. Confirmation of electrical continuity. B. Confirmation of mechanical security of attached lead wires. C. Confirmation of field coating at attachment sites. 4. Training competency of personnel. A. Trained on organization attachment procedures for CP and corrosion monitoring systems as well as protective coating procedures. B. Ability to take required measurements. C. Trained to perform cathodic protection surveys to identify potential stray current interference. D. Operator qualified to perform the task as applicable. 5. Records requirements. A. Pipe attachment report, which includes precise location of each attachment for correlation within line inspection reports. Total number of unsuccessful, successful attempts to attach the lead to the pipe. B. Coating inspection reports, including documentation of coating type, manufacturer, lot numbers, etc. Challenge number 35. Thank you for your time and attention. If you like to challenge yourself, please answer this question in the comments below. Training and competency verification programs should be defined for the personnel performing work which may be employed by the organization, contractor, or supplier. What should a training and competency program include?